The halogens, probably the most reactive group of non-metals in the periodic table, appear in group 7. Let me introduce you to the most wicked, nasty member of the family, and that's fluorine. Fluorine just loves his electrons, and you can see by looking at his electron configuration. All of the halogens are in the P block, and therefore, if we look at the position, they're in P5. So fluorine's electron configuration is 1s2, 2s2, 2p5. Being the most electronegative element in the periodic table, fluorine is just looking to fill its outer shell. Its nucleus has 9 protons. However, the fact that there's very little shielding between the outermost shell and the nucleus, fluorine just grasps the electrons and drags them to himself. And therefore, it's the most powerful oxidizing agent in the periodic table. Further down the table, we've got chlorine. Chlorine, fluorine's brother, isn't quite as reactive, and that's because of his electron configuration. As you go down the group, there is more shielding of the electrons by the electrons or the nucleus. Now let's take a look at chlorine. Again, because of the unpaired electron, chlorine can attract electrons and is also a powerful oxidizing agent, but not as good as fluorine because its nucleus is shielded by even more shells of electrons. Chlorine is a green gas and was used extensively in World War I as a chemical warfare. Many soldiers were blinded by this gas and also their lungs destroyed as the chlorine gas ripped the electrons from their lungs and damaged all the epithelial tissue. It was an evil chemical weapon. Nowadays, chlorine has slightly less innocuous uses in cleansing water because it is a very powerful bactericide. As you go down the group, the molecules are getting heavier and heavier. So just remember that they don't just go around on their own. No, they have to go around in pairs. So fluorine goes around as F2 molecules. Chlorine goes around as Cl2 molecules. And bromine goes around as Br2 molecules. And as they're getting heavier, each molecule, so here's some bromine molecules. As they're getting heavier, the van der Waals forces between the molecules is increasing, and therefore, as you go down the group, fluorine is a colourless, deathly gas. Chlorine is a dense green gas. And bromine is one of the only 2 liquids in the periodic table. Its name comes from the Greek bromos, meaning stench. It's a highly volatile liquid and extremely toxic because of the density of the clouds of gas that it gives off. So if you have in a bottle, it's a brown liquid. As soon as you take the lid off, these molecules escape and try and oxidize you. But it's not as bad as its 2 brothers as an oxidizing agent, again because of the shielding. And if we look at its position in the periodic table, there's fluorine, chlorine, bromine, then iodine. If we look at its position, it's in period 1, 2, 3, 4, and therefore its electron configuration is going to be 4s2, 4p5. So it's a less powerful oxidizing agent. It's not as good at stealing electrons as its brothers higher up in the periodic table because of the shielding of the nucleus. So already we can see the oxidizing power as you go down this group of nasty elements is decreasing. Fluorine is the nastiest oxidizing agent of them all. Then chlorine used as a poisonous World War II gas. And then bromine, or stinky bromine, or stenchy bromine, bromos, the only liquid, brown, horrible, smelly, nasty liquid. Almost at the bottom of the table, we've got iodine. Iodine, because it's the biggest, fattest molecule of I2, has got that many electrons around its molecules that exists as a solid crystal lattice held together by weak intermolecular forces, or van der Waals forces. Iodine is the weakest oxidizing agent of the periodic table due to the fact that its outer electrons are so far away in the 5p subshell, and therefore these outer electrons are shielded from the nucleus by the inner electrons. So these outer 5p subshell only feels a weak attraction of the nucleus in order to draw an unwitting electron into this 5p subshell. Right at the bottom of the table we have astatine, and astatine is so radioactive it only exists for a few seconds, but we could predict that it'd be even slobbier than iodine, probably a black solid, probably volatile when you heat it. And we could predict that the weakest oxidizing agent of all is this brand new element here, tennessine. Just heard of that. There's a new one, go and research it. So there's a quick introduction to the halogens. Oxidizing agents all have the P5 electron configuration. Powerful oxidizing agents, but the most powerful of all is fluorine. Here he is. Fluorine, come and see us, fluorine. P5, no, he's not doing it. So there in a nutshell is the halogen family. Look to the next video for how they displace each other or boot each other out of solutions of their ions.